this video, I'll solve GATE Physics 2016 question number 24. A hydrogen atom is in its ground state in the presence of a uniform electric field E, which is equal to E naught Z cap. The leading order change in its energy is proportional to E naught to the power n, the value of the exponent n. So the question is asked that the leading order correction, which will be proportional to E naught to the power n, so we will have to find the value of n. Obviously it will be a integer value. So to start with, we know that the ground state eigenfunction for hydrogen atom is 1 by pi a cube e to the power minus r by a, where a is Bohr radius. So for hydrogen atom, if we illuminate a light with a light, then the Hamiltonian will be h naught plus e r dot is the charge of electron. So we have taken as minus e is the charge of electron. So this is the unperturbed Hamiltonian of hydrogen atom, and this is the perturbation due to the illumination of light or electric field. So here we are concerned with h prime, which is because we need to find the dependence of E naught, so we don't need the constant value of V, so we need this only. So we have to find it, and obviously it will be E naught Z. So Z component of R is R cos theta, sorry. So it will be R cos theta E naught. So this came from, because E is E naught Z cap, and we have the dot product of with R dot E, and the Z component of R is R cos theta. So from there we have got this value of h prime. So let's first calculate the first order correction. So the first order correction is psi 100, and since n starts with 1 also here also, so we can write it as 1 as, so this one is for ground state because n starts with 1. So this is for the convention. So E naught R cos theta psi 100. So we'll have to calculate this. So this will be 1 by pi a cube is outside, e to the power minus 2r by a, because psi 100 is this one. So the volume element is, and r cos theta is there, and E naught, the volume element is r square sine theta d theta dr d theta d phi. So 1 by pi a cube 0 to infinity e to the power minus 2r by a r cube dr, and 0 to pi sine theta cos theta d theta 0 to 2 pi d phi. Now you don't need to do the total integration, you just do this integration, the theta integration. You will see that this part will give us 0. So we can do this, right? So this is sine theta cos theta d theta. Just replace sine theta as p, then cos theta d theta is dp. So if we just first do the integration and then we will put the change sine theta. So this is p dp, then it is p square, sorry, it will be p square by 2, and if we again change it, it will be sine square theta by 2, limit from 0 to pi, and this is definitely 0 because sine at sine pi and sine 0 both are 0. So this will give us 0. So the first order correction to the ground state is not proportional to E naught at all, because it is 0. So we need to go to the second order correction. Now this formula is, so you'll have to remember this formula. Here it will be n not equal to 1 psi n lm E naught r cos theta psi 100 modulus square divided by E10 minus En0. So we'll have to find this one. Now you can see that this value is not 0, because if you do this explicitly, NLM r cos theta psi 100. So since it is dependent on n not equal to 1, so n can be 2, 3, 4, anything, and for n equal to 2, let's say for n equal to 2, we'll have L equal to 1 and 0. So from there, n 1 0 and minus 1. Sorry. So for n equal to like 2, L will have 1 and 0, and m is from minus L to plus L. So for one value of this integration will not go to 0, because we have this function, the spherical harmonics, and this will depend on cos theta, sin theta, like this. So for one value of n, this integration will not go to 0. So this is not equal to 0, and E12, since E12 is not equal to 0, so we get that E0 square, it will dependent on E0 square. So we needed the first order, the leading order correction, and we have found that it is E0 square, so n equal to 2.